All right, problem number 5, we want to solve by factoring. And notice the progression. We started out with a quadratic equation, a full-blown quadratic equation, wanting you to see that when we have the x squared term, that is quadratic and we want to factor. And then slowly we're showing you how to factor what if this term was missing. So the previous problem didn't have a constant. And now this problem is missing the middle term and showing you that there are some special cases that still factor. So we want you to be able to do any problem no matter what it looks like. Now we can't go over every example, but we are doing our best to give you some differences and showing you what to do if terms are missing. So number 5, we have x squared minus 121. Alright, so this is a special case factoring problem. It is called difference of squares. Difference of squares says if you have a number squared, a perfect square, and you are subtracting, hence the difference part, it has to be subtraction, another number that is a perfect square, then it factors by using this formula, a plus b and a minus b. So that is saying that you take the squares away, you put those two together, add it, and subtract it. That's it. Or you take the square roots. You have to be able to see each number as a square. The nice thing about this formula, it works with even if you had multiple numbers here. So let me just give you an example. If I had 4x squared, let me just say that 4x squared minus, let's do 81 y squared z squared. So even though I have more than just one thing, that same formula holds. Even if these were bigger than 2, as long as they were even, the same formula holds. So let me show you, and then we'll do this one, because I want you to be able to do it no matter what it looks like, because you'll see something different and I don't want you to freak out. So 4 is a perfect square. We can write it as 2 squared. You don't have to do this step, but you need to know it. And then I can just rewrite it as x squared minus 81 is a perfect square. 9 squared is 81. So this is the same thing. And I'm just going to bring down y squared and z squared. All right, so look, perfect square. This is a term. And then perfect square. We're subtracting all of this multiplied together. So that's our two terms. All right, so when we factor it out, we take off the square, so it would be 2 and an x in the front, and then plus, and then in the back we would have 9yz. Let's take off the squares. 9yz. And then we have the same thing in parentheses again, only with subtraction. 9yz. And if you FOIL this out, you'll have a middle term, but one will be positive, one will be negative. They will cancel out, and you will end up with what we started with. So I want you to know that it works with 2. That's the basic form. But if you had more, and they were perfect squares, and you're doing the difference, and there's only 2 terms, and when I say 2 terms, they're all being multiplied together. This is one term. This is one term. So just 2 things. We can't have a third thing. So when I say a third thing, we can't have another minus sign and something else. So as long as you have 2 terms, subtraction, perfect squares, formula works. All right, so let's do our actual problem. X squared, and then minus 121, that is 11 squared. All right, so that is x plus 11, and then x minus 11. Also note, it does not matter if you change the order. Sometimes I may write the minus first, x minus 11, and x plus 11. It doesn't matter. Both of these are the same. Okay. So remember the commutative property again. So if I have 3 times 2, because we're multiplying, that is the same thing if I do 2 times 3. So don't think there's any difference if you change the order here when you're multiplying. So it wants solution set. So I didn't finish the problem. I just got the factor form. So this is equal 0. So we take each of these terms, x plus 11, x minus 11, set it equal to 0. So I have x plus 11 equals 0 and x minus 11 equals 0. Subtract 11 from both sides here, and that gives us x equals negative 11, and then over here we would add 11 to both sides, and that gives us x equals positive 11. So our two answers are negative 11 and positive 11. Sorry, that's kind of off the screen. Negative and positive 11.